This video addresses question 8 in section 7.4, and in particular, part B of that question. Is beta known in principle? If yes, can its value be stated from the information given? If yes, what is beta? To go back to the question, question 8 says, consider the hypothesis H0, the proportion of non-emergency visits at an emergency room facility is 0.35, and H1, the proportion of non-emergency visits is 0.45, to be tested at the 95% confidence level. The sample that will be used to test this will be a random sample of 80 records from all emergency room records for the past 3 years. So the sample is 80 records. Therefore, N is equal to 80. H0 says that the mean value, or the proportion, which is the mean value, is 0.35, and the blue distribution shown here has a mean value of 0.35. The standard error for a mean value of 0.35, calculated by the formula for a standard error of a proportion, is 0.0533. So the standard error that forms this distribution is 0.0533. Now, if we are to calculate beta for the alternative hypothesis of 0.45, we must find an upper limit for the 95% confidence interval around an H0 of 0.35. The upper limit is found by taking the mean value H0, the T for a one-tail limit for 0.95, which would be 0.1, and the degrees of freedom, which are essentially 80 minus 1, and the standard error. So the upper limit is the mean plus the t-value of 1.66 times the standard error of 0.05, and the red line here indicates approximately the 0.438 upper limit. Now, in order to find the value of beta, we are assuming that the alternative hypothesis of 0.45 is true. Therefore, the distribution around 0.45, represented by the purple, will have the standard error appropriate to a true value of 0.45, or 0.0556, which is slightly larger than the standard error for a true mean value of 0.35. Therefore, when we calculate the proportion of the purple distribution, which is to the left of the red line, we will base our calculation on the standard error appropriate for 0.45. Now, how do we conduct that calculation? Well, the first step is to take the upper limit for the mean of 0.35 Subtract the mean of 0.45, which is H1, and take the absolute value of that difference and divide that by the standard error of the proportion or mean of 0.45. That gives us a t-value that represents the number of t units that the upper limit for 0.35 is below the mean for 0.45. In this case, it is only 0.2 t units. Now, in order to determine what proportion of the distribution around a true proportion of 0.45 is below 0.2 t units, we must use the t-dist function with 0.2 as x, degrees of freedom being again 79, and one tail because we're interested only in one side of the distribution. When we do that, we find that beta is 0.42. If we calculated beta on the basis of the standard error of 0.053, which is the standard error for a true mean of 0.35, we would get an answer very close to the answer we got by using the standard error of 0.055, but it would not be precisely the right answer because H1 assumes a true mean of 0.45 and therefore a true standard error of 0.055.